Okay, as part of today's quiz, you were given this sequence and asked to extend it. And people did this pretty well, but a couple people kind of missed it, so I'll just quickly, we find the differences and we don't see a pattern. We find the differences. Well, we actually do see a pattern. They're going up by 6, but maybe you wouldn't see that if the numbers were a little uglier, okay? But this is going to go, 10, 6, 22, 28, 34, 40, etc. Always going up by 6. If you don't happen to see that, you go another step. And you see that, well, we get 6 and 6, okay? And then we assume that this continues with 6s, and then we can build up our numbers, okay? In other words, we get a bunch of 6s here, so 22 and 6 makes 28. Adding 6, we get 34. Adding 6, we get 40. Then 52 and 28 gives us 80. 80 and 34 gives us 114. 114 and 40 gives us 154. 102 and 80 gives us 182, etc. So we build up the original sequence. And if you don't happen to see the pattern here, you could subtract again, you get 0. Now if you had a couple more numbers out here, you keep subtracting, you would keep getting zeros here, and you would see that pattern would just have to hit you right upside the head, but you won't need to go to that extent. You go to here. The other next question, second question, was how do we add up this sequence, 100 to 1,000? We first notice that we can pair these numbers up, and they all add up to 1,100. Now we've talked about that before, so I'm not going to discuss it at too much length here, but each time for each pair we go up by 4 units here. This number is 4 units bigger than this one. This number is 4 units less than this one, so they add up to the same thing. And we're going to be able to pair up all these numbers. Then the only tricky question is, how many numbers do we actually have? Well, I'm going to say that there are 900 divided by 4 pairs, starting at 104, ending at 1,000. How do we get that? Well, let's just list the numbers 1, 2, and so forth, okay? Okay, for 1, we're going to pair that up with 104. 2 is going to pair with 108. So what's our last number going to pair with? Well, our typical number pairs with 100 plus 4n. If n is 1, 100 plus 4 times 1 gives us 104. N equals 2, 100 plus 4 times 2, well, that's 108. That's what we pair with 2. So we got something of the form 100 plus 4n that pairs up with 1,000. What's that going to be? Okay, well, we can set 100 plus 4n equal to 1,000, and we can solve that for n, and we find that n is 225, and that shows us that we've got 225 numbers. Another way to think of it, you got to go from 100 to 1,000. You got to make a number of jumps. From 100 to 104 is a difference of 4, and then from 104 to 108 is a difference of 4, and you're going to go all the way to 1,000 by differences of 4. Well, that means that since from 100 to 1,000 the difference is 900, we got to span 900 units in jumps of 4. Well, 900 divided by 4 is 225. So we got to make 225 jumps. How many numbers do we need if we're going to have 225 jumps? Well, we've got to start here, and then we make our first jump. So the number of numbers that we have here has to be one more than the number of jumps. Okay, so the number of numbers equals number of jumps plus 1. And that plus 1 is the number you start at. It's like fence posts. Okay, it's like each jump is a fence section. How many posts do you need? Well, you sink a post, and then for every section you need another post. So there's one more fence post than there are fence sections. There's one more number in this sum than there are jumps of 4. Okay, so we conclude one way or another, there are 900 over 4 pairs from 104 to 1,000. So there are, and 904 is 225. So I can write that out, that's 225. So there are 226 numbers, because you got to start with 100 before you can make your jumps. So how many pairs? You divide that by 2, and then you multiply the number of pairs by 1,100, and there you have it. Another way to write this is, if you go from 1 to n, how many pairs do you have? Well, you have n numbers, so they're n divided by 2 pairs. Even if n is an odd number, you end up with some whole number plus a half a pair. The half a pair is just that number that you end up with in the middle. And they each total 1 plus n. Okay, if you go up to 2 and down to n minus 1, well, you've gone up by 1, you've gone down by 1, the sum is still going to be n plus 1. So you have n over 2 pairs each totaling n plus 1, so the total is n over 2 times n plus 1. That's a perfectly good formula. But it doesn't apply directly to this sequence because this is not the set of numbers from 1 to 1,000. Okay, if we had the numbers from, let's say, 4 to 1,000, we could actually use this idea by pairing up the set of counting numbers from 1 to 250 with the numbers from 4 to 1,000. 1 times 4 is 4, 2 times 4 is 8, and so on. 250 times 4 is 1,000, so there are 250 numbers from 4 to 1,000. Okay, now if you've gone from 104 to 1,000, then you might pair those numbers up with numbers from 26 to 250. Then there'd be 225 such numbers. And then you'd add the number 100 and so forth. So by pairing up sequences, you can actually think pretty clearly about how to form a sum. In any case, for the numbers from 4 to 1,000, pairing them up, you see that there are 250 of them, and each of these numbers is 4 times each of these. Okay? So that if you were to add these numbers up, which you could do using this formula, and then just multiply by 4, you would get the sum of these numbers. So you could say this is 4 times the sum 1 plus 2 up to 250. 4 times this sum is this sum because you have the same numbers here but multiplied by 4. And that, if you just use the formula, is 4 times 250 over 2 multiplied by 250 plus 1 from the formula. So the formula can be quite useful. Now you see there are many different ways to look at this problem of adding up a sequence of numbers. You can look at one-to-one correspondences and work out some algebra. You can think of fence and fence posts. You can think in many ways. The bottom line, if you try to reason it out, is you want to know what each pair adds up to, and you want to know how many pairs there are. And that's often, it can often be matched up with the problem of adding the numbers from 1 to n. And the formula you get there is obtained in just the same way. But you can formally use this formula as in this example. Okay? Now we're into a chapter on problem solving, and in problem solving, you want to see all the connections you can. You want to make all the connections you can, and you want to find connections that lead you to a solution.